Thank you. I think the mic is working, so we can start. All right. Yeah, thanks firstly for inviting me. It's an honor being on this stage. It's like, wow, amazing. Anyway, I'm Matjaž. I work at Aldren, formerly known as Zemanta. And today I will be speaking about multithreading Javascript, a look into WebWorkers. So to start, if we just look at the first part of this title, like multithreading JavaScript, maybe some of you can say that, there is like a typo or something, or it's not correct, right? Because we all know that the JavaScript runtime is single-threaded, right? And it can perform one action at a time. But then if we keep reading, like a look into WebWorkers, maybe it makes sense, right? And my goal today is to kind of bring you a little of insights into WebWorkers, so that when you leave, you can say that, or you will not guess anymore, but you will say, I know that this title makes sense. Okay, so let's start. What are we going to do today? I hope I made it short, but we'll see. So firstly, we will start by defining the problem that we had in our production app. I would really like that, all of us are on the same page. That's why I will take a few more minutes to describe the problem. And then I will try to fix the problem with using WebWorkers. And I will also explain what WebWorkers are, what is the API, how we should use them, and some tips and tricks about. And yeah, at the end, I will just summarize everything so that you can have like a slide of the most important takeaways. Okay, so the problem. The problem is, I call it the blocking UI. So basically, this is like a piece of code that runs on, the JS runtime, and it runs for a longer time, okay? And in that time, the runtime can do or can process any user interaction that the user is doing with an app in the browser, like scrolling, clicking on some buttons, drop-downs, popovers. Everything is basically frozen, or it looks broken, right? And we had such an issue in our production app for quite a while. And I have like a short video, and apologies for my video editing capabilities. I couldn't show you the data because it's production data, right? So then I just blur everything. But the main point is the network tab. I hope it's gonna be nice, and let's try to make it work. Okay, so the video starts after the app is already bootstrapped. Okay, we can see that a lot of stuff is already loaded. I'm currently clicking on some actions, in the header. Now I think I'm trying to scroll or whatever, right? But nothing works. Everything is broken, feels broken, right? And after some time, like a few seconds or even more, we can see here in the network tab that there is like a request that it's loaded, okay? We can see that we loaded from the server about, 50 megabytes roughly, okay? And after this is done, okay, boom. It starts working, okay? We can process, we do the scrolling, we do the clicking, everything works but after the fact, right? And having such a blocking UI or a blocking code in, production app is bad. That's a red flag, you should fix it, right? So let's move on. Some insights over the problem, right? The UI was unresponsive for more than 5 seconds, which is bad. It happens on every load, so every time we bootstrap the app, we are using Angular, that's why I keep saying bootstrap, and this problem happened twice, every time. So it was really bad. But let's say the good side of the problem was that it happened only for internal users, okay, not for all our users. By internal users, I mean users that have access to see all our entities that we store. All our campaigns or our ads, accounts, whatever, right? It happened on all the mobile devices that was really visible, and it it happened also on desktop browsers like Safari, Chrome, Firefox, but not every time, okay? I kind of tagged the Safari because with Safari, I was able to really understand the issue at the end and then solve it. Chrome and Firefox, they are just, I don't know, they are doing a great job. Anyway, initiator. So yeah, the initiator of everything, right? We saw that we have, at least before in the network tab, we had some API/nav that is loading a lot of data. In short, this first API call, right, was getting all the entities that the user has access to, but not all the properties. So we are not like fetching the entire database, but just, I don't know, the IDs, the names, stuff like that. Okay, but, and we are also putting like a query parameter, load status is equal to false, so we just want, you know, the basics. And then the second one is like load everything, okay? We also get the status, for instance, of a campaign, whether it's running or it's post, for instance, right? And we can see that the first request, you know, it was about 30 megabytes and the second about 50, okay? And yeah, that's why twice we had the blocking UI code. But now why, right? I mean, let's try to understand it. So I started, you know, debugging and stuff, and I kind of come to this code. So it's an ordinary Angular JS HTTP client. Okay, we are executing a get HTTP call, providing the URL and some configs. And then in the success callback, right, we are getting the data, so that 50 megabytes of data. But, you know, to be honest, we are not like doing any magic here. So why the blocking code, right? And in order to understand this, you know, problem more in details, I started basically teaching myself how the JavaScript runtime works. And the first, let's say, key, you know, takeaway for you guys is I really recommend checking the video. I recommend checking the article, and now I will check the demo, which kind of really nicely explain how the runtime works. And to start with, we have, you know, in the, let's say, V8 engine runtime, there is only the call stack, okay? So that's what is there. And basically, you know, each operation that is kind of implemented in the JS code then gets added, so pushed to the stack, right? And the runtime basically pops from the stack and executes the action, okay? That's what the JS runtime is doing. And because we have one call stack, the JS runtime is single-threaded. It can take one operation from the call stack and execute it, okay? Then we have something called in the browser, something called the web APIs. If we, you know, try to understand Node.js, web APIs would be C++ APIs, for instance, right? And then it's something called the callback queue and the event loop, okay? And if I now try to run this command here, where is it? Oh, 7 run. Okay, we can see that, right, maybe I should scroll a bit, or maybe I should zoom out so you guys can see a bit. So basically what we are doing, we are printing to the log task 1, then in the set timeout function, in the callback, we are printing task 2, then task 3, and task 4. And now the question is, like, we saw that task 1 was added to the call stack, was executed, then set timeout was added to the call stack, disappeared. And then after 5 seconds, the callback came back to the call stack, how it works, right? So basically, the set timeout calls a web API, which triggers a timer. After the 5 seconds, when this is done, the callback is added to the callback queue. And the event loop is that piece in this puzzle that basically has a very simple job. Checks the call stack. When the call stack is empty, that's really important, okay? When it's empty, checks whether there is some element in the callback queue. If it is, push the element from the callback queue to the call stack, and the runtime executes it, okay? So that's why maybe, at least me, a lot of times I found in Stack Overflow like a comment, you should just put set timeout to 0 and it should work. Okay? Basically, what we are saying, we are just postponing the execution to the callback queue until the stack is the call stack is empty. So all the other stuff, it's processed in between. Switching back to the presentation. Oh, okay, cool. So let's move on with the presentation. What happened? Okay, I guess it should be. Okay, here it is. Apologies. Okay, so then with that knowledge, we can apply, instead of the set timeout, we can kind of apply the get call, right? That the HTTP, the AngularJS client is doing. So what that get call does is basically executes an HR call, like triggers the HR call from the web APIs, does the job. When the data is fetched from the server, okay, it pushes the callback, right, that we saw before, to the callback queue, and once the stack is empty, it pushes the callback queue to the call stack, okay? So if you remember before that code, our own code was not doing anything, like really remapping that huge array or whatever. So we didn't have like the blocking UI problem, right? So then I debugged the HTTP source code of, the AngularJS HTTP client source code. And I found out this. So they are, adding for us a callback, success callback, right? Where they are, before the payload actually comes to our callback that we define, it flows that huge payload through the JSON.parse function, okay? I'm not saying that JSON.parse is slow or whatever. This is like extremely optimized operation. You should use it all the time. That's good. Now also it makes sense that why, the issue was not that, was not constant, was not always present. Like I said, Chrome and Firefox does a great job, but putting here like a 50 megabytes of string can cause some issues also in Firefox and Chrome. But at the end of the day, this was the root cause, okay? And what can we do, right? I mean, what? It's like, that needs to be parsed before we can use it in the code, okay? So then I started investigating into some possibilities, how to, do that in some other way, okay? And yeah, I started looking at WebWorkers. So I would just now read its theory. So a web worker are a simple means for web content to run scripts in background threads. Run scripts in background threads, makes sense. The worker thread can perform tasks without interfering with the user interface. Nice, okay? So that probably can solve the issue, right? Like I would push the JSON.parse to the web worker. He would do the heavy lifting, just return to the main thread, the browser thread, everything already parsed, and we're done. But before we get to the solution, let's firstly see a bit of the WebWorkers API. So the WebWorkers have a really, I would say, nicely defined and well-documented API. So we have like a feature detection, right? So from the browser main thread, you can call window.worker and you see if the worker is supported or not in the browser. If not, you can then do some fallbacks. Spawning a worker is really simple. You basically just execute new worker and you provide the path where the JS code that needs to run in the worker is located. Then you have, like two functions, how to post the data to the web worker and how to retrieve the data from the web worker to the main thread. Okay, so posting the message and then you can kind of create like on message handler when the worker does the job and posts the message back to the main thread, you will get the data here. There is a simple command to terminate the worker, and of course you also have like an API that is called when something was raised in the web worker itself. So there was like some error or whatever, right? So a really simple API. Okay, now some more, let's say, theory. Why use WebWorkers? Improve application performance and enhance user experience. Sure. Application logic doesn't block UI main thread. Makes sense because you offload some stuff to the web worker thread. And what kind of really also triggered me is that it's very well supported. So this is like a screenshot taken from Can I Use, and we can see that most of the browsers actually supports web workers. Not sure about the Opera Mini, but I don't know. Okay, anyway, what are the limitations? Yes, in the web worker you can't access the DOM API. So no get element by ID or something. No shared memory with the UI thread, which is also, in my opinion, really nice, to be honest. It increases the CPU, but it increases the CPU and memory utilization of the client's machine. Sure, I mean, just by creating a new thread, there is some payoff that is addressed with that. Okay, and now let's see the solution. So basically, even though the worker API is quite, let's say, simple and well documented, I didn't want that every time we would kind of wanna use web workers to do some job, for the developer to really understand all the documentations and whatnot. So that's why I tried to create such a solution that kind of kind of mimics or all that web worker specific stuff kind of put it abstract in a way, right? And that's why I thought of this solution, okay? And basically, app.js is the JS bundle where our Angular app is implemented, and the worker.js is the bundle for the worker, okay? Now, let's maybe start on the app.js. I created like a worker service, okay, which encapsulate all this magic around web workers, how to detect if the worker is supported, how to post the message to the worker, how to get the message from the worker, how to handle errors and fallbacks, okay? So basically, a developer, if he or she wants to push something or offload something to the web worker, only needs to know about the worker service. It has a simple, only one function, run worker, and that's it. And then the magic happens in the worker bundle. Basically, it's created as a action dispatcher, okay? So we have one action dispatcher that has like a really easy interface. It's got a topic and a payload. The topic is like a string, a constant, right? And it defines each action, right, should be triggered when that message with that topic comes to the worker, okay? And the payload can be anything, right? And then the appropriate action is detected, the action handles the work, and it returns the response back to the main thread. Also, worth mentioning is that I said like the worker has an interface like the topic and so on, and also can have like some helper functions that are already defined in the main thread. Okay, and what I wanted to achieve is that I can have like a shared folder to put all this common stuff that can be used in the main thread and in the worker thread in the same place, so defined once, but used multiple times. And I configured Webpack, we are still using Webpack for bundling, to basically, put this code into both bundles, so in the worker and in the main thread bundle. And with this solution, right, the developers in our dashboard should only worry about defining the topic that needs to be handled in the worker and then the implementation of that action. That's it. All the, let's say, web worker related stuff, it's hidden away from them. And after this was done, this is, okay, maybe another, I hope you guys see it, another screenshot from how we are now calling that HTTP GET call. So before we only saw this method, right, in the previous screenshot. Now this is extended. So as I said, from the main thread, we only know about the worker service, okay, which has one single entry point, which is the run worker function, gets some action topic and the payload. And maybe here I should put another, let's say, key takeaway, is that when posting messages from the main thread to the web worker, those messages should be as small as possible. Why? Because the main thread is doing deep cloning before posting the message. And if you post like a huge message to the web worker, that operation can become a blocking UI operation. Okay, and we can see when the worker stuff is done, the then callback is executed, and we get the data back. Okay, and all the magic with JSON.parse and fetching those navigation was done in the fetch navigation topic inside the worker. Okay, and then this is like a fallback. So if the worker is not available in the browser or there is an error happened in the worker, the catch callback will be executed, and for simplicity we just do the previous work without the workers. With this approach, we solved the issue, and there was a really, finally I was able to kind of put this message to our internal Slack, saying that we deploy several optimizations to the dashboard user interface, so things like, and this was like a copy paste from one of our internal users complaining about, that the dashboard was not working as it should. So other times the dashboard seems to lag while scrolling or opening panels, etc., should be now resolved, and you should experience a much more responsive UI. They were quite happy about it. And the final slide is key takeaways. Always try to write non-blocking code. Here is like a really good article that also kind of teaches you how to write non-blocking code with a very specific example over how to re-implement for loops by using set timeouts in order to offload or to postpone the execution of several blocks so that the main thread, handling scrolling and stuff like that can still run smoothly. Then about web workers, here is also an interesting article. Some things that I said are already maybe more in details even explained in this article as well. What is, I think, important to know that a web worker essentially is a JavaScript file, JavaScript code that will run on a background thread, not on the main thread. Okay? There are a couple of challenges when using web workers. You have no DOM, there is no shared memory with the UI thread. And another, like the tip that I said, right, repeating, always post small messages, not like me, pushing, from the beginning that 50 megabytes because I was kind of testing why it's not working. I thought that, remapping that was the blocking UI operation, but it was not. It was the JSON.parse thing, and I was trying to push all that to the web worker, and it just didn't work. And when to use it? Parsing a large JSON string, okay, that's one example, and other heavy stuff like image, sound processing, And that's it. Thank you.
Before we start the QA, for anyone who's gonna ask the question, try to have the mic as close, but not like awkwardly close to you. So my question would be, once you introduce the abstraction layer in your application, how did other people start using that as well? So did you start adding more and more cases, and did that go too far in some cases?
So to be honest, my case, so this blocking UI issue was the only, let's say, use case for web workers in our app. So in a way, I was over-engineering a bit with the worker service, but you know, it feels good.
As we do. Thanks.
Hey, thanks for the great talk. I think web workers will become a really big thing in the future and also now. You said that the problem is that you don't have shared memory with the UI thread. Have you looked into transferable objects where...
Well, that's a good point, yeah.
Yeah, so you can actually share the memory, and but it's limited, yeah, to some specific cases like buffers, streams, images, I think.
It has some limitations, yes.
Yeah.
For instance, in my case, it was not really a good idea to do any like such transmissions between the worker and the main thread.
Yeah, in this case, it makes sense not to use it, but it's an option for anyone that needs it.
Matjaž, thanks for the intro to the web workers. You mentioned that you have issues sending lots of data from the main thread, from the main program to the workers. Are there any problems sending lots of data back?
No, that is not a problem because the worker is doing the deep cloning, and you get just data to the main thread. No problems
so you
there.
get a huge object of JavaScript.
Yes,
okay.
Yes.
Good.
Hi, thank you for the great talk. Like we're always having this issue, like, yeah, we know we're having the web workers, but in which cases should we use them? Are there any more cases that you could like encourage us to use them? You said like JSON parse, then image processing, sound processing. Is there something else, or we could just like say the rule of the thumb should be, okay, use it if you're having the heavy computation and this is blocking the UI?
Yes, I would say that. So maybe my advice would be do not complicate with web workers from the get-go. If, use the main thread, there are a couple, good, advices that how to implement non-blocking JavaScript code. Like I said, the article before, if you have like a really huge array that you need to remap, maybe it's better to process it in chunks, and between each chunk you call like set timeout just to release the call stack to the JavaScript runtime to do other things as well in the meantime, right? But even if this doesn't help, then switch and try web workers, because even though web workers has quite a simple API, right? It takes some time to integrate them properly or production ready to your app.
Hi. So one thing that a lot of people, let's say, hate about Redux, right? You have an action that is happening in some black box, right? And the architecture that you showed here kind of looks the same, right? So you have an action, and if the developer didn't wrote that code, they don't really know what is happening. Were you thinking about the case where you could bring that web worker code closer to the developer so they have a context about, okay, I triggered one action, what is that action doing for me?
Actually, I was trying to do the opposite, right? To really abstract the workers from the other developers to make the API as simple as possible. But if I didn't then kind of do a lot of experiments, like I said, it was one use case, we solved it, we were done. But in my opinion, we should, at least I try really to make, to abstract this, let's say, low-level stuff. In my opinion, using web workers is low level. Like, right, posting the message, having the callbacks when the message returns back and stuff like that. And, in my opinion, they should be abstracted as more as they can be, right? So that the development of new features, like if, for instance, now we would need to add a new code to the web worker, a developer would kind of take a couple of minutes to do that. And that was my goal.
Yeah, sorry, maybe I was not clear. I was not really referring to the API to the worker, but the action that you are doing, right? That action is stored somewhere. That worker don't have a context where they're calling this action, right?
Aha, okay.
Right, so not the API, but you are executing something in, let's say, main thread, but you don't know which code you're executing. What is this doing actually in the worker, right? Because it's in other location, in that sense.
Well, yeah, I mean, we have, I don't know how to even answer that. So I developed it, I know what I was doing, right? Maybe that's a valid point, I guess. Like if this would be like super useful or used across, maybe some optimizations in that way should need to be done. Like making sure that, the shared, I guess you are referring to the stuff that is also in the shared folder, like I mentioned, the helper function, the constants and stuff like that. Why is there and not just on the main thread?
Yeah. Okay, thank you.
Anyone else? Yeah.
Just a quick one. Can you debug the code inside the worker, or just like the other code in the? Like, can you put a debugger inside of it somehow?
If you develop this on localhost, yes. Also in production.
Okay. Always in production.
Yeah, I was wondering how do you approach testing the web workers, especially the integration between the actual worker and the main thread?
Oh, that's a good one. Try and fail, in my case. So, we have like a suite, to be honest, that tests the UI, and I heavily relied on that as well. So that I was sure that before deploying something in production, it will work. And also, worth mentioning here is that if I would do like some mistake in the worker itself, by the way, the worker was unit tested, so the functions, like the actions and the dispatcher, that was unit tested, of course. But even though if there was like some sort of exception raised and not handled properly or whatever, it will come back to the main thread, right? And then the worker service that I implemented, instead of going to the success callback, would go to the error callback, where the fallback code was located. So in any case, I knew that it will work.
Awesome, thanks.
Anyone else? No. Okay. Thank you so much for this.
Thank you.